Hi there, my name is Srikant Tiwari, and in this video we will see that how to convert decimal number to binary number and binary number to decimal number, and then binary number to octal number and octal number to decimal number, and finally binary number to hexadecimal number and hexadecimal to decimal number. So let's start our journey with decimal number. It has 10 digits represented by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 10 digits, therefore the base, often called radix of decimal number, is 10. Sometimes, to avoid any confusion, we also write this base value in subscript. For an example, 81 base 10. That shows 81 is a decimal number. Here a number is given 254.57. We can express this number in this place value method. In order to express this number in this place value method, first of all we have to find the place value of each digit. For integer part, we start counting from right to left and start counting from 0. So 4's place value is 0, 5's place value is 1, and 2's place value is 2. For fractional part, we count left to right. So 5's place value is -1 and 7's place value is -2. And then we have to write each digit multiply by its place value, and then so on. So 2 into 10's power 2 plus 5 into 10's power 1 plus 4 into 10's power 0 plus 5 into 10's power -1 plus 7 into 10's power -2. 2 into 10's power 2 become 200. 5 into 10's power 1 become 50. 4 into 10's power 0 become 4. 5 into 10's power -1 become 0.5, and 7 into 10's power -2 become 0.07. If we add all these values, we get 254.7. We end up with the same number. So we can express this number in this form, and we end up with the same number. Binary number. In the binary system, we have only two digits, 1 and 0. Hence the base of this system is 2. We call it bit and can represent any number using these two numbers as a string form. For an example, 101.010.101. 1 and 0 bits of binary systems and decimal systems 1 and 0 are equal. That is, binary is 0 equal to decimal 0 and binary is 1 equal to decimals 1. They have same value and same meaning. Binary number to decimal number conversion. Here an example is given: convert binary number 11010.11 into decimal number. We can convert this binary number into decimal number by using place value method. So first of all, we have to find the place value of each digit. So for integer part, we count right to left. So 0's place value is 0, 1's place value is 1, this 0's place value is 2, this 1's place value is 3, and this 1's place value is 4. For fractional part, we count left to right. So this one's place value is -1 and this one's place value is -2. Then we write each digit multiply by its place value and so on. So 1 into 2's power 4 plus 1 into 2's power 3 plus 0 into 2's power 2 plus 1 into 2's power 1 plus 0 into 2's power 0 plus 1 into 2's power -1 plus 1 into 2's power minus 2. 1 into 2's power 4 becomes 16. 1 into 2's power 3 becomes 8. 1 into 2's power 1 becomes 2. 1 into 2's power minus 1 becomes 0.5. And 1 into 2's power minus 2 becomes 0.25. If we add all these values, we get 26.75, which is decimal equivalent of this binary number. Nice and simple. Decimal number to binary number conversion. It is easy to convert decimal number to binary number. To do so, we have to handle integer and fractional part separately. For integer part, we convert integer part to binary by repeated division by 2 and separating the remainder till we get 0 as quotient. For fractional part, we convert fractional part to binary by repeated multiplication by 2 and separating the integer as we get it till we have all 0 in fractional. Let's understand through an example. Here an example is given. Convert the 50.1875 into binary number. This is a decimal number and we have to convert in binary. So first we deal with integer part. So we bring this 50 here and 50 divided by 2. We get 25 as quotient, 0 as remainder. And then 25 divided by 2, we get 12 as quotient, 1 as remainder. And then 12 divided by 2, we get 6 as quotient, 0 as remainder. Then 6 divided by 2, we get 3 as quotient, 0 as remainder. Then 3 divided by 2, we get 1 as quotient and 1 as remainder. Then 1 divided by 2, we get 0 as quotient and 1 as remainder. Now our algorithm will halt because we get 0 at the quotient part. And we read it from bottom to top. So 1, 1, 0, 0, 1, 0 is a binary equivalent of 50. Now we see the fractional part. 0.1875 multiplied by 2, we get 0.375. Here integer part is 0, so we write 0. Then 0.375 into 2, we get 0.75. Here integer part is 0, so we write 0. Then 0.75 into 2, we get 1.5. Here integer part is 1, so we write 1. 0.5 into 2, we get 1.0. Here integer part is 1, so we write 1. And because we get 0 at the fractional part, our algorithm halted. So, and we read it from top to bottom. So 0, 0, 1, 1, which is binary equivalent of this 0.1875. Hence, the binary of 50.1875 is 110010.0011. Very simple. You might want a fast way to convert decimal number to binary number. So here a fast way using which we can convert a decimal number into binary number in a fast way, in a quick way. So first of all, first create table of place values like this. And then in respect of integer part, find the next less than or equal to binary place value number from the table. Then subtract binary place value from decimal number. Then repeat the step 1 to 2 till we find 0 on step 2. After obtaining 0, assign 0 on all other places. It's time to demonstrate this method. So here an example, convert decimal number 68 into binary number. So first of all, we write place value table and then find the next less than or equal to value from place value table in respect of 68. So we find 64. So we write 1 underneath 64. And then we subtract 64 from 68, we get 4. Then we try to find next less than or equal to value in respect of 4. So we find this 4. So we write 1 underneath of this 4. Then we subtract 4 from 4, we get 0. Because we get 0, so we write 0 on all other place values. And that's all. So we find the binary equivalent number, which is 1 0 0 0 1 0 0. Nice and simple. Binary number to octal number. It is straightforward to convert binary number to octal number. Base of octal number is 8 because it has 8 digit systems. 0, 1, 2, 3, 4, 5, 6, 7. Let's understand through an example. Convert 110011.0011 to octal number. In order to convert binary number to octal number, we have to create a group of 3 digit. For integer part, we create group from right to left. So our first group have 110, so we write 110, and then next group have 101, so we write 101. Because only one digit left, so we write this left digit here. And for fractional part, we count left to right. So our first group have 001, so we write 001. Only one digit left, so we write here 1. We have to complete the group of 3. So for integer part, we add remaining zeros before this digit. So we added 0, 0. And for fractional part, we add remaining zeros after this digit. So we write 0, 0. And now a table of octal number and its binary equivalent number is given. It is very easy. You do not need to memorize it. It's very simple. You can, if you do some example, you can easily get it. So we have to write octal number underneath of this binary number. So first binary number is 001. We see the chart and find this one here. So we write 1. For 101, we find 5. So we write 5. For 011, we find 3. So we write 3. For 011, we find 1 again. We write 1. 100, we find 4. So we write 4. So 153.14 is a octal equivalent of this binary number. Very simple. Now we convert this octal number to decimal number. In order to convert any octal number into decimal number, we can do it by place value method. So first of all, we have to find the place value of each digit. So for integer part, we count right to left. So 3's place value is 0, 5's place value is 1, 1's place value is 2. And for fractional part, we count left to right. So 1's place value is -1, 4's place value is -2. 1 into 8's power 2 plus 5 into 8's power 1 plus 3 into 8's power 0 plus 1 into 8's power -1 plus 4 into 8's power -2. 1 into 8's power 2 becomes 64. 5 into 8's power 1 becomes 40. 3 into 8's power 0 becomes 3. 1 into 8's power -1 becomes 0.125. And 4 into 8's power -2 becomes 0.0625. If we add all these values, we get 107.1875, which is decimal equivalent of this octal number. Nice and simple. And now we will see the hexadecimal number. It is also straightforward to convert binary number to hexadecimal number. Likewise, octal number. Base of hexadecimal number is 16 because it has 16 digit system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then A, B, C, D, E, F. It has 16 digits. Therefore, the base value is 16. Now, we try to convert binary number to hexadecimal number. Convert binary number 11.0011.0011 to hexadecimal number. To convert binary number to hexadecimal number, we create a group of 4. So for integer part, we create group right. We count from right to left. So our first group have 1, 1, 0, 1, 0. So we write 1, 0, 1, 1. And our next group have 0, 1, 1. So we write 0, 1, 1. And for fractional part, we count left to right. So we count 0, 0, 1, 1. So we write 0, 0, 1, 1. And because here one digit, we need to add one digit here. So we add 0 here. Because it's an integer part. So we write 0 before these digits. And then we have to see this table, the hexadecimal and its binary equivalent number, and write the number below these binary numbers. So for 0, 1, 1, 0, here we find 6, so we write 6. And for 1, 0, 1, 1, we find B, so we write B. And for 0, 0, 1, 1, we find 3, so we write 3. So 6B3 is hexadecimal equivalent of this binary number. Nice, very nice. Now we have to convert hexadecimal number 6B.3 in decimal number. So we can do it by using place value method. So first of all, we have to find the place value of each digit. So for integer part, as we did, we again do. B's place value is 0, 6 place value is 1, and for fractional part, left to right, so 3's place value is -1. And then we write each digit multiply by its place value and so on. So 6 into 16 power 1, because its base value is 16, so we write 16. 6 into 16 power 1 plus b into 16 power 0 plus 3 into 16 power -1. Now we have to find this b value of this b and its decimal equivalent. So here is a table is given. We can find its decimal equivalent, which is 11. So we replace this b by 11. And we know that anything's power 0 become 1. So we write 1. So 6 into 16 power 1 become 96. b into 16 power 0 become 11 into 1, which is become 11. And 3 into 16 power minus 1 become 0.1875. If we add all these values, we get 107.1875, which is decimal equivalent of this hexadecimal number. That's all. Nice and simple. Thank you. Thank you very much.